Okay, let's get going. We are going to dive right into week 9. Okay, so there's lots of topics to discuss in week 9. In this particular video, we are going to look at using the graph of a distribution to find probabilities, and we're going to learn how to shade a region and find its standard normal probability. And there'll be a couple more videos going over these next set of concepts. All right, so let's jump in. Okay. When you first start off in week 9, you are going to be given a little graph, and they're going to ask you to find probabilities. So there's usually 3 questions that you'll be asked. Let's try to get this a little clearer here. Yep. Okay, so the graph of the probability distribution is shown below. The graph is made up of 2 line segments, so that one and that one, or that one and that one, and a curved path. For each part below, suppose a real number is picked according to the above probability distribution. Do not round any of your answers. Okay. So the first question is, find the probability that the number picked is between the number 2 and 5. Then it's going to be between 5.5 and 6.3. And then find the probability that the number picked is 6. All right. So some things that we need to make clear is all of this area underneath this this curved section, these 2 line segments, the area is equal to 1. All right, so the whole thing is equal to 1. If you, let's just say, own some land, think about that as like 1 acre. That's your 1 acre there. So the area is equal to 1. All right, a couple other things that we're going to need to bring into play here, and it's some geometry. So the first thing is recognizing and remembering area of a rectangle. Okay, an area of a rectangle, if you recall, is length times width. Okay, so if you had, and really it probably should look like this. Here's width, here's length. All right, so let's say your width was 3 and your length was 4. 3 times 4 would be an area of 12. All right, so area of a rectangle, we're going to need that. We're also going to need to remember the formula for area of a triangle. So area of a triangle is 1/2 times base times height. So you want to have these formulas close. Area of a rectangle is length times width, and area of a triangle is 1/2 base times height. So let's just say you had a triangle down here, and let's say the height was 6 and the base was 12. Okay, so it would be 1/2 times 12 times that height, which is times 6. So that kind of makes sense if you think about a triangle as being half of a rectangle, right? Half of a rectangle would be, well, 6 times 12 would be your area of the rectangle, and then just take half of it, right? Like when you cut your sandwich in half like that on the diagonal. Okay, so we know that all of the area underneath here is equal to 1. We've got our formulas ready. And so let's start off with the first question. Find the probability that the number picked is between 2 and 5. Okay, so here's 2 and here's 5. I'm just going to draw like a little line there. Okay, so they're trying to find the probability that you pick a number and it falls between 2 and 5. So somewhere in here, that's the question mark. Okay, so it's kind of difficult to tell what that piece is. Is it a third of 1? Is it? It's not a half. We know it's smaller than a half. So we're going to section up what we know into a triangle and a rectangle. So you can draw yourself a little line here. And now we've made a rectangle. And then there's a little natural triangle here. So if you think about this, if we know the area is equal to 1, and we can figure out the area of a rectangle minus the rectangle, and the area of the triangle minus the triangle, then that should give us the question mark area, this piece right here, right? Because the whole thing's equal to 1. Let's subtract out this and that'll leave us that little missing piece there. So it's 1 minus the area of the rectangle minus the area of the triangle. Okay, now let's look at the axis. We have our x-axis and we have our y-axis. So our x looks like it's in increments of 1, and the y-axis comes up to 0.25. Let's start with this rectangle here. All right, so the rectangle, we know has a width, all right? We need length and width, right? We got a width of 2, because that's 1, 2 right there. So 2 times the height, which is 0.25. So the area of the rectangle is going to be equal to 2 times 0.25. The area of this triangle is equal to 1/2 times this base. Let's look at this base. So it's also a 2, and the height is still 0.25, same as the height of that rectangle. So once we get our area of our rectangle and our triangle, let's pin that down, and we can subtract both of those areas away from 1, and that'll leave us with that missing link there. Okay, so you're going to break out your calculators. I'm going to do 2 times 0.25 and get 0.5, and 2 times 0.25 here, divided by 2, which is really multiplying by 1/2, is 0.25. All right, if you have a fancy calculator, I could have done 1 divided by 2, like times 2 times 0.25, and still gotten 0.25. You could convert 1/2 to 0.5 on a regular calculator. 0.5 times 2 times 0.25, still going to get 0.25. All right, so we know that this whole thing is equal to 1. So 1 minus the area of the rectangle is 0.5, minus the area of the triangle is 0.25. Well, so let's think about what we got here. You have, let's say, an acre of land. You're going to take away 1/2 an acre, and you're going to take away 1/4 of an acre. So what are you left with? Hopefully 1/4 of an acre. Yep. So the area of that question mark is equal to 0.25. All right, so that gets us to part A. Part B, find the probability that the number picked is between 5.5 and 6.3. So now they're talking about somewhere between here and here. So this little slice in here. All right, so now they're wanting to know what's the probability, or that area, that the number picked is between 5.5 and 6.3. Okay, so this was part A. Let's look at part B here. Okay, so if you want to, you can even kind of sketch that out so that it's not so messy. You know, mine's kind of messy here. So here's 5.5. Here's 6.3. We know what the height is, 0.25. So we're really looking at the area of that rectangular piece there. Well, we have to figure out what that width is. So the width is the distance between 5.5 and 6.3. So what is that? Well, $6.30 minus $5.50. If you think about this, if you like to think about decimals in terms of money, which is what I think about, it's going to leave you 80 cents. Okay. So the width is 0.80 times the height. Remember, the area of a rectangle is just length times height. So 0.25. And that's going to give us that probability that the number that is picked is between 5.5 and 6.3. So 0.8 times 0.25 is going to leave us with 0.20. So we think this little chunk, right, is roughly 0.20 of the whole 1 acre. So it's like a fifth, 0.20. Okay, find the probability that the number picked is 6. Okay, well, here's 6. So I'm going to draw a line right through it. There's 6. Okay, so this is part C. Well, it really doesn't make a rectangle, right? The width of 6 is just equal to 0, right? There is no width if you're just on 6 right there. You're not like in between anything. It's just at 6. The height is 0.25. Well, if you want to multiply, length times width to get that, that segment there, you're going to get 0 times 0.25, and 0 times anything is just 0. So the probability that the number picked is 6 is actually a 0. So that's an example for for this type of question, I have a second type of question loaded in here for you. So I'm going to show that to you and let you work on that. And then I'd love for you to pause and come back and see if you have the answer that matches my answer. Okay, so let's take a look at it. Okay, here's your new piece of your graph here. You've got same sort of questions. Find the probability that the number picked is between 1 and 5. Keep in mind, this is 0.15 is your new height. Find the probability that the number picked is 8, and find the probability that the number picked is between 6.3 and 7.7. So go for it, pause, and come back. Okay, feel free to forward this video as I try to catch up to you at this point. All right, probability that the number picked is between 1 and 5. Well, I'm going to draw myself a little line segment here. This is the question mark. So hopefully you built yourself a rectangle and a triangle. So we know it's going to be area is going to be 1 minus the rectangle minus the triangle. Okay, so let's figure out the rectangle. The width hopefully was 1, 2, 3, 4. The height is 0.15. So for the rectangle, hopefully you got 4 times 0.15. And hopefully you got 0.60. Okay, or 15 cents times 4. This triangle has a base of 2. It's going to be 1/2 times 2 times the height of 0.15. So let's see here. Ooh, it's quite a glare there. So I'm going to go 0.5 times 2 times 0.15. Okay. So that's going to be 0.15. Okay, rectangle, triangle. Okay, so to find this missing chunk here, we're going to do 1 minus the area of the rectangle minus the area of the triangle. So think about it as an acre minus 0.60 of an acre minus 0.15 of an acre, and that's going to leave you 0.25, which is the probability that you pick a number between 1 and 5 right here. So this is 0.25. Okay, so hopefully you got that for part A. Part B is find the probability that the number picked is 8. Well, here's 8. It's really not a rectangle, so the width is equal to 0. The height is equal to 0.15. Length times width, or, height times width is 0 times 0.15, which is 0. So the probability that you pick 8 exactly in here is going to be 0. Okay, part C. All right, you might not have been able to see that. So this is 6.3 and 7.7. So let me make that a little better there. So 6.3 is right here. 7.7 is right here. So just looking at this little chunklet right in here. Okay, so we got to figure out what is the difference or that width between 7.1 and 6.3. So 7.1 minus 6.3 should leave you $7.10 minus $6.30 leaves you $1.40 or 1.4. That's going to be your width. 1.4 times your height, still 0.15. So 0.21 hopefully is what you're getting for the probability that you'll pick a number between 6.3 and 7.1. So that little chunk is just 21 or 21% of that whole area, which is 100%. So you got your 25%, you got a little chunklet of 21%. So hopefully with a couple examples now, you're feeling a little more confident if you weren't confident before you walked into these. And let's move on to the next topic. Okay, the next topic is shading a region and finding its standard normal probability. The standard normal curve is graphed below. When they say standard normal, like curve, they mean it has a mean equal to 0 and a standard deviation equal to 1. So there's your mean of 0 and it deviates 1 on either side. Okay, so here's the standard normal curve. Shade the region under the standard normal curve to the left of the z-score 1.50. Okay, so remember a z-score kind of runs kind of below, right? So this is our z-score. 1.5 is positive, so it's going to be above the 0, and 1.5 looks like it's right here, 1.50. Okay, so if I kind of just sketch that upward, they're looking, that was a terrible line. Let's make that a little nicer here. They're looking to find out what is, if so, everything, something that we need to make sure that we know is that area under this curve is just like with those other problems we were working with. So the area under the curve is always going to be equal to 1. Yep, you guessed it if you were thinking 1. So they're looking to see how much of this area is taken up to the left of z equals 1.50. That's your z-score. Okay, now in your packet, you have the video and then of course these slides. And then I made a z-score chart. Now, if you'll see here, it says use this table or the ALEKS calculator to find the area under the standard normal curve. Give your answer to 4 decimal places. So I actually took some snips of the table. I don't use the ALEKS calculator. You're welcome to. I just never tried it. I'm kind of old school. So I just printed out some screenshots of all of these z-scores and the corresponding area. So let me show you how this kind of works here. So this table gives you a z-score and an area that goes with it, and a z-score and an area, a z-score area, z-score area. And it's always the area to the left of that z-score. So for example, here's 0, right? And we know that if we were to cut this curve in half, this is 50% and this is 50%, right? Or 0.5 plus 0.5 equals 1, right? 50 cents plus 50 cents equals $1. We'll take a look at this. The z-score is 0, right? There's the z-score. And the area is 50%, 0.5. So that's the area over there to the left. So we're going to be using this chart when we're asked this question here. It says, what is the area, to the left of z equals 1.50? Well, we got to comb through this. All right, and it's going to be quite a few pages you might have to comb through. You're looking for a z-score of 1.50. So I'm going to just start looking until I find a z-score of positive 1.50. Ah, I found it. Okay, here's a z-score of 1.50, and it has a corresponding area of 0.9332. Okay, so then it's 0.9332 is going to be that area that's to the left of the z-score of 1.5. So that z-score is just basically saying if 0 is your average, it's wandered away from that average 1.5 deviations to the right. So it's above the average there. And that makes sense that this piece of this curve is 0.9332, right? It's 93.32%. There's only like a little missing chunk right there, which is like the other 6 or 7% right there. So that makes sense if we think about it. All right, let's do another one. This is just going to take some practice. Okay, the standard normal curve is graphed below. Shade the region under the standard normal curve to the left of z equals negative 1.50. Okay, so here's 0, negative 1, negative 2. So right here is negative 1.50. And they want everything to the left, which is great because that's how the charts work. They give you area to the left of the z-score. So I'm going to go to my z-score chart and look for negative 1.50. Okay, so I'm looking for where z is negative 1.50. And I see it right here. It's 0.0668. Okay. Let's see if that makes sense, right? If we were to convert that to percentage, it would be 6.68%. That's that little piece right there out of the whole 100% underneath that curve. So that makes sense. If this was like, 56%, you would think to yourself, that can't be right because half of this is 50%. Well, this is less than half. much less than half. So they're looking for 0.668. Make sure you go out 4 decimal places. All right, we're going to do it again. Use the standard normal curve that's graphed below. Shade the region under the standard normal curve to the left of z equals 0.50. Okay, so here's 0. Here's 1, so 0.50 is right here. So we're going to kind of draw that vertical line and sketch this. So hopefully you're thinking it's definitely over 50%, right? It covers that 50% and a smidge more. So we're going to go to our area and z-score chart and look for a z-score of 0.50. Here we go. Just going to start combing through looking for a z-score of 0.50. And I see it right here. So that's the z-score is 0.50. That corresponds to 0.6915. So area equals 0.6915 when our z-score is 0.50. So that's the answer that we'll be looking for. And let's see if that makes sense. That's roughly 69.15%, right? That makes sense. It's more than 50%. All right, it's almost 70%. All right, let's try another one. All right, we have 2 more examples in this video, and I might be overkilling it here, but I just want to make sure before we move on to the harder types of problems that you're comfortable using your z-score charts. Okay, the standard normal curve is graphed below. Shade the region under the standard normal curve to the left of z equals 2.0. Well, here's 0, here's 1, here's 2. Okay, to the left of 2.0, that's a big sizable chunk. We know it's over 50%. We know it's less than 100%, so it's somewhere in between. So z equals 2.00. Let's go to our area under the curve chart, our handy dandy chart, and we're going to start combing through and looking for where z is 2.0. And I see it right there. The corresponding area is 0.9772. So area equals 0.9772. And that makes sense. 97.72%. Yeah, I can agree with that. So they're looking for this as far as a decimal answer. But if you like to convert it to percent, just to help your, like for me, my hamster does much better when I'm thinking with percentages. And I think, okay, well, that's 50%. And then there's a whole other sizable chunk. So I think that could reasonably be 47.72%, right? It's just minus this little piece here in the corner. All right, one last problem. Let's take a look at it. The standard normal curve is graphed below. Shade the region under the standard normal curve to the left of z equals 0. Okay, well, z equals 0 is right here. This is everything to the left. And you're probably thinking, Parcel, I don't even need the chart for this, right? If this is the z, because we know it's 0.500. All right, we know that. That's the area with the z-score is equal to 0. It's half, right? It cuts that thing exactly in half. But for giggles, we're going to go find z equals 0. Boom, there it is. And it's 0.5000. I'll put another 0 on there since they want 4 decimal places. Okay, hopefully this video was helpful to get you started in our journey in week 9. See you in the next video. Bye.